We're just going to talk a little bit today about our chemical treatment offering. So certainly across the Auckland region, but across most regions across the country now, there is a requirement with any project of significant size to implement a chemical treatment plan. So what does that look like? Well, starting your project, you'll have your erosion and sediment control plan in place. This will detail your pond design, the basics of the site, you know, where your silt fences go, and similar, your controls, your clean water, your dirty water diversions. But you'll also need a chemical treatment plan for council approval. And what does that detail? That details the project location and the nature of the works. Bench testing from one or more soil samples from site is taken to ascertain chemical dose rates. We also detail methodology, so that's likely to be rainfall activated dosing into an SRP, but it might also involve flow-based dosing if you're pumping into another pond or a clarifier or similar. It's going to have all your maintenance reporting requirements in there and everything you need to demonstrate that you're going to be competent when you're applying your chemical dosing out there in the field. So the really good thing about Cirtex is all that bench testing and that ctmp is put together in our accredited lab. So our Cirtex laboratory holds an ILAC MRA IANZ accreditation to the ISO 17025 standard for its scope of testing. So basically this is a world-class third-party accreditation which demonstrates a high level of independence and accuracy, which gives you as a customer absolute certainty that that report's been done to the highest possible level. So the lab itself, yeah, it's a state-of-the-art lab. It's equipped with state-of-the-art world-class equipment and has that full independent accreditation. So it just gives you absolute certainty as a customer that everything's being done to the highest possible level. So the bench testing itself, the chemicals we'll typically use in New Zealand are the go-to chemicals, polyaluminium chloride. That's not exclusive, so if there is but we do find we use polyaluminium chloride because it works really well across all our soils. It was the first chemicals used in New Zealand, and it works very well across the whole range of New Zealand soils. So the bench testing is all done in our laboratory. So most council requirements have a requirement for clarity and NTU, but there's also a requirement for TSS as well. So what are we looking at? Clarity, we're typically dealing with, that means basically looking at 100 mil of clarity through the water column itself. NTU requires a meter which actually reads light, and TSS is total suspended solids. So that's actually again a lab process that we can do for you that involves drying the solids that are in the jar themselves and weighing those out. So our lab has the facility to do all those requirements, the TSS, the NTU and clarity, and correlate those accordingly. So the cool thing about that is if you've got to do TSS reporting on site, typically to get a TSS test you've got to go to the lab and you're going to wait a week for your results. But when they can correlate those results and the ctmp versus clarity, you can get a very good understanding of what that looks like, TSS looks like in relation to clarity. So as you can see in our test report here, we're recording a clarity, we're recording our turbidity, our total suspended solids, and our pH as well. So that's really important because when we do add the likes of polyaluminium chloride, you'll see there is a bit of a drawdown on pH with incrementally larger dose rates. pH, most guidelines are based on maintaining in a range between 5.5 and 8.5, with pH 7 being neutral. In those zones, the water discharge from site is regarded as non-toxic and therefore safe for discharge. So when we just look at the bench testing itself, this is just a typical example we've got here on the screen. So bear in mind all these jars were equal, so it's taken from a soil sample on site, that soil sample's mixed with rainwater, and then it's stirred vigorously, and then the sediment-laden water is decanted off and put into 6 equal jars. The jar on the left has had no chemical treatment, and then incremental dose rates in there, typical 2, 4, 6, 8 and 10 ppm. So what we're trying to achieve is clarity typically around that 4th jar. We don't need swimming pool quality, as you can see in jar 6. What we're trying to do is just make sure we've got that 100 mil of clarity. So we can see through that jar, those jars are 100 mil thick, so we know in that example there, jar 4 is getting us into the compliance zone. So we're going to be typically trying to achieve somewhere between jar 4 and jar 5 for compliance on site. Jar 1, clearly without chemical treatment, there's a large percentage of that sediment is remaining in suspension. Jar 2, again, we haven't got enough chemical dosing. Jar 3, we can see we're starting to get good sediment accumulation on the bottom of the jar itself. Again, you can see that increasing quite substantially, Jar 3, Jar 4 and Jar 5. And it also puts into context when you think about the dirty water leaving your site, and you think, oh, it's just a few cube or whatever it might be of dirty water. When you start to see that sediment accumulated on the bottom of those jars, you can put into context how much sediment is potentially going to leave your site and then either settle out in stream beds or in estuarine environments as it reacts with salt water. So that's a really key component for you to look at when you read your ctmp. It's going to give you a good understanding of that relationship between dose rate and clarity on site. So we really try and detail that with visual pictures in our chemical treatment plan. The other report page of this report that's really important, again, is the lab report. So this is going to give you your clarity after 0, 5 and 30 minutes. It's going to detail your incrementally increased dose rates of floc, typically polyaluminium chloride, and then related clarity that's been achieved with that, the NTU, that being the turbidity, total suspended solids if that's a requirement for your project, pH, and we also just record the temperature as well. So that's the key components of the report that are going to give you an understanding of the outcome. Okay, so again, there's a really good example here, just that correlation between TSS and turbidity and clarity. So again, when you're coming back to your council reporting, you get a really good understanding of how your clarity, your live clarity that you're recording on site can be translated into a real TSS result that you can report back to council on. So in relation to, once we've done your ctmp, once Cirtex have completed your ctmp, we'll then continue the journey with you in relation of the supply of materials you'll need. So we still do the standard GDO5 flock shed. This was a system designed by a chap called Mike Larkham in conjunction with Auckland Council going back about 15, 16 years ago now. Really, really clever system where fundamentally we have rainfall landing on a catchment tray on the roof, which is sized according to catchment area and dose rate. That's passed down into a header tank, and the header tank primarily allows for the accumulation of rain pre-dosing. So obviously if we've got dry ground and it hasn't rained for a period of time, we get a light shower, we're not generating overland flow. But we'll typically get overland flow kicking in after around 12 mil of rain. So our header tank allows for accumulation of the first 12 mil in the header tank itself, and then the water passes via a low flow and a high flow hose in higher rainfall events into a displacement bucket. So that displacement bucket starts as empty, it will fill up with water, push down on a chemical bucket, and in turn pass the chemical out, displace the flocculant out through a dosing hose into the entrance channel of the pond. So it's a really, really clever system. We love it because it's static, there's no electronics, there's very little that can go wrong with it as long as simple checks are done to check that pipes are free of debris and similar. So we still supply the standard large flock shed and junior flock shed, mini flock shed. However, we have designed a really, really cool system, awesome system called the Porta Flock, which replicates the exact principles of GDO5, and we have this in a standard and a large. There's so many benefits with this system. It's easy to get onto site, set up half an hour max, half an hour to an hour. Adjustable trays, screens to stop debris, your really cool little header tank tube that you just drill the low flow and high flow in. Really clever level indicators just showing you your exact levels in the displacement system at any one time. You'll see on the gauge there, we've got a green going through yellow through red zone. Principle of that basically is we don't want our system to run out during a large rain event. So we always try and keep it in the green zone. So it's good practice after every rain event. Check our levels, do our reporting, we'll check our pH, and as part of that process and our checks and our reporting, we'll replenish the system as well. So we've got a really cool internal drain system on the Porta Flock. So rather than the requirement to actually take lids off, to take out water from the displacement bucket, etc., we can simply open the tap, which is connected to the internal drain. That in turn allows the water to leave the displacement tank, and then we recharge the system itself. So really good practice to keep that system recharged and in the green zone, because we don't want it running out of chemical in a major rain event. We've got really nice fill points, so we just simply click our IBC or our drum pump onto these fill points, which makes everything really, really easy to get up and running. So when we look at the porta flock itself, what we've tried to do is basically make this system as simple and as user-friendly as possible for you without compromising the principles of the original GDO5 flock shed, TP90 GDO5 flock shed. So starting at the top, we have, our tray system here allows, if you notice on the top tray there's holes on one side. So that allows for the catchment to be simply reduced or enlarged depending on which way round we point it. So if they've got the holes facing inwards, then that's effectively the top tray is shedding water down onto the bottom tray and increasing catchment area. But equally that can be reversed and angled back, and then that will reduce the tray size as well. Now that's on a really nice little track system, so that's really easy to adjust. If you think back to the shed system, we might have 2, 3, 4, up to 5 square metres of tray at the top, which is all timber and ply. And to modify that, we've literally got to get a step ladder out, get up there, put battens on there, drill further holes to shed additional water. So really quite complicated to change roof sizes on a traditional shed, and in reality we found that often didn't happen. So really, really simple system here for adjusting tray sizes. We can also add a secondary extension tray as well. So that gives you the ability, on the standard porta flock, that gives us the ability to take tray sizing out to 1.5 square metres. And on the large porta flock, that gives us the ability to take it out to around 4.2 square metres. We come down, we've got the header tank. So that's protected by the screen. You can see there part number 5. And then the header tank holes itself are drilled into a removable tube. That's part number 9. And then we have the bucket itself, which is the header tank, which holds the water. So as the water accumulates up through the header tank, it passes out through the header tank holes and down into part 10 there, the displacement tank, which in turn then pushes down on the chemical reservoir and passes the flocculant out through the dosing hose. Now we supply the chemical itself in both 200 litres drums and IBCs. I really do encourage wherever possible to use IBCs. Very, very difficult to have an afterlife for the 200 litre drums. Recycling is extremely difficult to achieve in New Zealand with the 200 litre drums at this point. 1 or 2 are good for Waratah bins and things like that, but if you use the IBCs, they have a good afterlife. So when you're looking at drums or IBCs, obviously on really small catchments with low dose rates, drums are often the most practical. However, they are much harder to have an afterlife for drums in New Zealand and recycling. Sometimes you can just refill them on site from larger IBCs, but IBCs come with several benefits. Firstly, you can gravity feed. I'm going to show that process shortly. So you can actually gravity feed your units themselves, whether it's a standard or large porta flock. But the IBC itself has an afterlife. They make really great water tanks around site. They end up in people's back gardens as water tanks and similar. They've always got a bit of a value associated with them as well. Whereas 200 litre drums tend to end up in the landfill sites. Also with the 200 litre drums, you've got a pump. So you either use a hand pump, or there are some electric or petrol pumps that are available. However, the corrosive nature of the flock itself mean that your pumps will have a life. So the gravity filling simplicity with the IBC is my recommendation every day. So here's just a nice little sort of typical setup of your dosing system in situ. So in this example, we've got, as I say, gravity feeding from an IBC, and we've got our porta flock tucked away up to the side, out of harm's way. We're dosing about 5 metres back into the entrance channel, so we want really good mixing prior to the flocculant entering the fall bay to the pond itself, and we're going to achieve that. So what we've done here as well is we've implemented some socks just to create a concentrated flow at the dose point. You can see the dose point sitting about 6 inches above the ground. Too high and that flock can blow around in the wind, and too low and it can potentially get buried in sediment. So we position our dosing hose around 6 inches above the ground, as you can see in this diagram. We've also put some geotextile in there around the dose point. Obviously when we're concentrating flow, we're increasing the risk of scarring erosion. So another couple of nice examples here out in the field. Again, this client set theirs up for gravity feed replenishment. The trays have all been set up accordingly. Just another good example here. Again, this client's gravity feeding. So when doing our test work out in the field, you don't need to go and buy the expensive lab clarity tubes. Our requirements are 100 ml clarity, so This is a nice little kit we've made up. It has the Secchi disc or grid on the bottom, you have your measure up the side, and that will give you all the readings you need to be ascertain whether your discharge is compliant. Remembering that we need 100 ml typically for most consents. So we have to record our pH. We need to bear in mind that we can use either strips, pH strips, or we can use a meter. Now, pH meters will typically give you that good accuracy down to 2 decimal places, which pH strips won't, but pH strips are 100% reliable as long as they're kept dry and out of the weather. You do have to be mindful with a pH meter, but they need to be calibrated regularly. They will potentially go out of range and lose their accuracy if they're not well calibrated on a regular basis. So just be mindful of that. The other part, obviously, that Cirtex provide for you is full in-field training and support. So take this back to the start of the process. We put together your chemical treatment plan for you. We will ask you whether you've got existing dosing systems you want to use on site. You might have some old sheds or similar systems that you may want to use on site, or we'll make recommendations accordingly. So that'll be implemented in a chemical treatment plan. So then we make those recommendations, we'll agree a time with you to come to site, and we will do all your setup and installation training for you. Make sure that everyone on site has got understanding of their clear responsibilities. We'll show you how to do your clarity testing, your pH testing. Now, that support doesn't leave you there, we're there for the duration of the project. So I can often assist remotely. A recent example, we had a chap down in, a client down in Christchurch recently, where they had clarity issues outside. They were dosing as per their chemical plan, but for a number of reasons they weren't achieving clarity on site. So we got them set up remotely to do effectively some bench testing on the back of their ute. They could understand exactly their shortfall and flocculant and batch dose immediately. So that support is there for your duration of your project, which I think is hugely important because things change on site. Your soil types will change, your open areas will change, and sometimes you just need that on-site assistance to get you through. So we're there for the duration of the journey. We also have this great resource, the Civil Dosing Hub. So the great thing about the Civil Hub dosing calculator is that it allows you to adapt as your project adapts. So as your site increases or reduces, you will need to adjust your header tanks and your tray sizes accordingly. Your pond is always sized for your catchment area, that's the water landing in the catchment itself, but your dosing systems may need to change your tray sizes and your header tank holes because you're closing or down or opening areas, or simply your soil types have changed and your dose types have changed, your dose rates have changed. So we can go to the Civil Hub, we detail the project, the location. That's going to be typically as per the details in your ctmp. We can amend our catchment areas, amend our dose rates. We can then select the system we're using, whether it's a shed, a flock box or a porta flock, and that will generate the new catchments, the new detail sizes you need. So that will have the new roof tray areas, the new header tank sizes, and now you can put that back in your ctmp as an amendment. So the cool thing about the dosing calculator is you can put in your new catchment areas, any new dose rates, that will create there, and then select the unit you're using, whether that be a flock box, a porta flock or a shed, and then that will generate the new tray sizes, header tank holes, etc. You can then put that in your ctmp as an amendment in the appendix, and then when the monitoring officer comes to site, you've got full understanding and justification for your current sizings on your system. So there's a great resource on the website as well. Beyond the personal support you get from myself and Cirtex, the greater team, we've got really good video resources on the website, being the flock shed overview and workflow. We have the porta flock dosing system on there with a full installation setup guideline, and then going down to the back end of the pond, just all the support with things like your decants and similar.